What happens when the world's most powerful telescope is built in the driest, most desolate place on Earth? In Chile's Atacama Desert, scientists are constructing a massive telescope that could peer deeper into the universe than ever before. But how do you build something this monumental, where life barely survives? The Atacama Desert is the driest place on Earth after Antarctica. In some parts of this vast desert, no rain has fallen in recorded history. The question remains, how will this telescope peer back in time, unveiling the first stars, galaxies, and planets of the universe? What new discoveries will it offer, and what difficulties did scientists face while constructing a dome as massive as a football field in this remote, desolate region? In the videos, we get a glimpse of this extraordinary place. Chile's Atacama Desert stretches across 1,000 kilometers of coastline. It's so dry that it's considered the second driest place on Earth after Antarctica. The landscape here is like nothing we've ever seen, with volcanoes, vast salt-filled deserts, and fog that spans thousands of kilometers. These unique features make it feel like an alien planet. It's no wonder that the European Space Agency tested its Mars rover here. But there's something essential for life that's completely absent: water. It's so dry that in some areas, rain has never touched the ground. This harsh environment might look like something from another world, which is why scientists chose it for this groundbreaking project. A telescope like no other. Atop a mountain 10,000 feet above sea level, 1,300 kilometers from Chile's capital, Santiago, and 130 kilometers from the nearest city, the world's largest telescope is being built. This massive telescope, known as the Extremely Large Telescope, ELT, is part of the European Southern Observatory. Though still under construction, it's easy to see why it earned its name. The ELT will feature a giant mirror 39 meters in diameter, 4 times larger than the biggest telescope we've ever known. This mirror will gather light 100 million times more efficiently than the human eye. But there's a catch. Not a single speck of dust can fall on it. To protect it, the telescope will be housed in a gigantic steel dome weighing a staggering 6,000 tons, roughly the weight of 2,400 pickup trucks. Building in the unlikeliest place. Now the real mystery. How did the construction team manage to build this colossal project in such an isolated place, where there's no nearby population, no roads, no electricity, and no water? The project head explained that after many inspections across Europe, they finally chose this remote location in South America, where members of 16 European countries came together to make it happen. There are many reasons why this site was chosen, and as we watch this monumental project unfold, we can't help but wonder what incredible discoveries await us once the telescope is finished. Choosing the perfect location for the telescope. The first challenge the team faced was finding a location for the telescope that was far from any nearby cities. Why? Light pollution. You may have noticed that even on a cloudy night, the glow from city lights can often be seen above the clouds. This light is far stronger than the faint light of a star, even 1,000s of light years away, and it can ruin the sharpness of images captured by the telescope. While there are mountain locations in Europe that could work, they weren't ideal for one important reason: the sky itself. Europe, with its tropical climate, is often covered by clouds. On the other hand, the Atacama Desert in South America, one of the driest places on Earth, experiences clear skies for 320 out of 365 days a year. This makes it the perfect location to study distant galaxies and stars. After tests in 2010, the team chose a mountain called Cerro Amazon, standing 3,000 meters high. But there was a problem: the challenge of building on a sharp mountain. Unlike the more gently sloping mountains of Europe, Cerro Amazon was extremely sharp. Building anything on its steep peak would be almost impossible. The team needed to flatten an area as large as 7 football fields on top of this mountain. Imagine the task: a 3,000 meter high mountain with a massive construction project looming on top. This task was too dangerous to complete with just hand tools, so in 2014, explosives were brought in. The team drilled holes into the mountain's peak, planted explosives, and detonated them remotely. The explosion was powerful enough to blow away 100 meters of the mountain's top, removing 4.7 million cubic meters of rock and soil. Enough to fill 1,911 Olympic-sized swimming pools. With the dirt and rock removed, the peak was smoothed out and a path was built to the top. But this was only the beginning. Once the area was flattened, the team discovered a serious new issue: sinkholes. They were appearing at various spots across the mountaintop. Each time the engineers filled one, another would form. It became clear that the explosives used to flatten the peak had caused damage to the core of the mountain. Cracks had formed in the rock, and the soil started to sink. The engineers were left with no choice but to find a way to stabilize the land. After months of struggle, the engineers decided to use a method known as vibration drilling. This technique allowed them to stabilize the ground, filling the sinkholes all at once. It took a lot of time, but eventually the land was level again. However, this was only the first step in preparing the mountain for the massive foundation required to hold the telescope. Building the foundation in an earthquake zone. But the work didn't stop there. This part of the Atacama Desert is seismically active, meaning earthquakes are common, and so the next monumental task was to lay the foundation for the extremely large telescope, ELT, a foundation strong enough to withstand earthquakes and hold the enormous structure in place. The foundation for the telescope was carefully designed to protect its most sensitive components from the shaking of earthquakes. It was separated from the upper dome by hydraulic shock absorbers that prevent seismic shocks from reaching the metal dome and the telescope's precious mirror. The foundation work was completed in 2023, and the focus shifted to the dome itself. At the base camp below the mountain, the steel structure for the dome was constructed in pieces. These massive sections were then transported to the top of the mountain using remote-controlled trucks. Once at the summit, cranes carefully assembled the parts, much like a giant game of Legos. A road network already in place to reach a nearby telescope, the Very Large Telescope, VLT, was extended to Cerro Amazon to bring in the materials needed for the Extremely Large Telescope, ELT, the Giant Mirror. The key to ET's power lies in its gigantic 39-meter-long mirror. Inside the dome, a structure is being built to hold this massive mirror in place. The mirror is made up of 800 smaller mirrors that work together to capture light from space. This light is directed to the secondary mirror, M2, then onto M3, and finally M4, where the image becomes sharper with each step. Powerful lasers, tuned to excite sodium atoms 90 kilometers above the Earth, will create artificial stars. These stars serve as reference points to help the telescope adjust for atmospheric distortion, a process known as adaptive optics. Once the distortion is corrected at M4, the light moves to M5, where the image is finalized and sent to the telescope's processors. This advanced technology allows the ET to create clearer, sharper images of distant space objects, revolutionizing space exploration. The biggest question surrounding ET is its ability to directly photograph exoplanets, planets outside our solar system where life might exist. Using its enormous mirror, the telescope can collect vast amounts of light, enabling scientists to analyze the atmospheres of these distant planets. By studying their atmospheres, we can learn if these planets have essential elements like water, carbon dioxide, or oxygen, ingredients that might support life. Moreover, ET will allow us to peer deeper into the universe's past than ever before. Light travels at a fixed speed, meaning we can look back in time by observing the light that takes years to reach us. For instance, when we see the sun rise every day, we're actually looking at the sun's past, because the sunlight takes about 8 minutes to reach Earth. The Hubble Space Telescope can look back 13.4 billion years, capturing light that left the universe 13.4 billion years ago. However, with its massive 39-meter mirror, ET can peer even further, back 13.5 billion years, observing light from 100 million years earlier than Hubble. The cost of the vision. The cost of ET's construction is estimated at a staggering $1.6 billion, or 13,600 crores, the same amount that experts say was spent on building the world's tallest building, the Burj Khalifa. ET's construction is expected to be completed by 2029. Once finished, this massive telescope may hold the key to answering one of humanity's most profound questions. Are we truly alone in this vast universe, or is there life on a planet like Earth, located thousands of light years away? And there you have it, the incredible journey of building the world's largest telescope in the unforgiving Atacama Desert. As this groundbreaking project nears completion, we're closer than ever to unlocking the secrets of the universe. Don't forget to like, share, and subscribe for more amazing discoveries.